side and read, and just remind yourselves of some of these things that we learned back in elementary school. All right. All right. So you see all our place value names, and one of the things that we start with in this lesson is rounding. So somebody just clue me in. What's the rule again? Like if I wanted to round to the hundredths place right there, part A, what do I look to? What do I do? Somebody get me? All right, go for it, Alex. All right, good. So if I'm looking to round, if my instructions, like let's say this is an ACT test, they say round your answer to the nearest tenths place, then I'd look at the tenth place. I'd look one spot to the right of it, and I'd see, as Mr. Went just said, if it's 5 or above, I round the 10th place up. If I'm looking at the hundredths place, look one spot to the right. So check this out. Here we go. What we'll do is we'll ask Paul to mute himself since he's got some desk noise that's coming through my speakers here. We'll look at the hundredths place. Okay. So George, what digit is in the hundredths place? All right, 7 is in the hundredths place in this example. So I'm going to look one unit to the right of that 7. I see a 9, it's 5 or above, so I round that 7 up to an 8. So we would have 18.38. That's cake, right? Num, num, num. Give me some more. I love it. We had some angel food cake yesterday for lunch. It was delish. Well, not for lunch. It was after lunch. Y'all ever eat the angel food cake? Andrew knows what I'm talking about. Oh, yeah. Had some strawberries, a cool whip afterwards. It was excellent. All right. The tenths place would be a 3. All right. Josh, what do I do? Keep it at 3 or round it up to 4?
Round it up.
Round it up. Okay. And then it says round to the nearest whole number. Okay. Now that might seem a little strange when we talk about whole numbers. Will Edwards, where's the whole number spot? Yeah, that's where the 8 is. Okay. So 8's more than 5, so I should round it up, right? Oh, I got a couple people. I saw some heads nodding. No, that was a trick, Reed Johnston. If we're rounded to the nearest whole number, I'm looking at 8. I go where? I look to the right. I find that 3. So 18 would be where I keep this. That's rounding it to the nearest whole number. Just a little reminder about rounding. Not anything super hot and heavy, but that's basics, right? That's fundamental. That's like at baseball practice. During the first week of practice, Coach Kelso always has me have the guys out there running bases. And we talk about basics of running. Okay, I mean, you've been running since you were knee high to a grasshopper, and yet we talk about some basics so that we can be successful at that. You know what I mean? So this is basics, rounding. Any questions that you got about rounding? All right. Now we're going to get into some operations with decimals. Now, operations with decimals work the exact same way they always have. I'm not throwing anything new at you again today, like I said. Okay, but it's a smart move when you're doing operations with decimals to consider the signs. Okay, to consider the signs. We talked about the set of integers. These are non-integers, right? Integers are positive or negative counting numbers. So like negative 23.5 is a non-integer. It's actually called a rational number. Okay. And when we're dealing with decimals, in this case, these rational numbers, we want to keep our signs straight. So just before we actually get into this example, remind me, if I have a negative and I subtract something from that negative, the result is guaranteed to always be what? A negative, okay? If I have a negative and I add something to it, what?
You get a smaller negative.
Or
Or a positive if it's
positive.
big.
Good. So the notion of positives and negatives, additions and subtractions can be well understood with the notion of a number line, okay? So again, I'm preaching to the choir here, but if you got 0 right here in the middle of your number line, and I like how I see pencils moving. I only saw one of them actually moving. When you guys are taking these notes, do so diligently. You know, if I've got my number over here, right? And I say I want to add something to that number, I'm moving it in the right direction. So where it stops is TBD, to be determined. But the notion of adding means I'm moving it to the right. All right. The notion of subtracting would mean, ooh, I'm moving it to the left. Right? Left, right, left, right. Anybody play golf? I play golf. I play Army golf. You guys ever played Army golf before? You know, Army golf goes right, left, right, left, right, left, right, left. I bet Oxley gets that joke. Oxley, do you play golf like your brother does?
Yes, sir.
Yeah, there you go. My buddy and I, Philip, was a couple of weeks ago. We were playing out at Galloway before some in service, and it was cart path only, or we were walking or something. No, it was we were walking, and I swear it seemed like every hit, I would slice it and then I would hook it, and then I would slice it and I would hook it, left, right, left, right. But that's neither here nor there. Y'all don't want to hear about my golf game. So what do I do here? When I've got decimals and I'm trying to add and subtract, how do I set this problem up, Nate? Okay. So we put negative, if you didn't hear that, he said put negative 23.5 on the number line. So maybe like where our little asterisk Dewey is, maybe that's negative 23.5. In which direction are we going to therefore go? To the left. All right. Now, here's a general rule of thumb. Okay. With addition and subtraction of positive and negative numbers. If the signs are the same, tally it up and take the sign of of what they were. So when I say tally it up, I mean sum it up, add it up. So a general rule of thumb is that if I see, and I hope you wrote that down, if I see that both of those values are negative, then I know my answer is going to be negative because as Nate just said, I'm moving to the left. I started to the left of 0, I'm moving to the left of 0. So tally those numbers up. We got 41.38. We got 23.5. Notice, how did I tally them up? I lined them up vertically. You don't really have to do it that way. Y'all are capable of adding in your head. I know that. But we're kind of talking about some basics here. You know, when we tally them up, what do we get? 88 and 64. And the result is going to be negative because both of those were negative to begin with. So negative 64.88. Okay. Now, you might say, Coach Morgan, this is stupid. I've got a calculator that can do this for me. I've been doing this since the 3rd grade. What gives? Why are you teaching this to me in an honors algebra class? Because for one reason or another, okay, this type of problem is one of the most frequently missed problems in algebra for high school students. Okay, I don't know why that is the case. Dave, are you battling a mosquito out there? Sorry. I had one, in my car this morning. I killed it, and it was a bloody mess. I mean, it literally got blood. It was up on the roof of my car, or whatever you call it, and I went, and then there was blood. It was just, it was gross. It was a massacre. But this is back to this problem. This is one of the most frequently missed kind of areas for students, just because they rush it. They know it's easy. It's something simple. Okay, it's like the ephus pitch in baseball. Y'all know what the ephus pitch is? Y'all ever heard of the ephus pitch? Okay, you got a guy that's thrown in the 90s. All right, and then all of a sudden, same mechanics, same motion, same everything. He floats one in there about 50. Okay, that's called the ephus pitch. Now, a 50-mile-an-hour pitch for a professional hitter, he ought to be able to crank it. But a lot of times he whiffs at it just because he is, kind of caught off guard or not paying attention or not ready for it or whatever. This here is the ephus pitch. Doing stuff like what we got on the screen here is the ephus pitch, okay? Now, talk to me about multiplying. Mr. James Jacobs over here, I bet is a good multiplier. What do I keep straight as far as the signs go on my multiplication, James? Like, look at example 3 here. How do I know if this is going to be positive or negative?
There's an uneven number of negatives.
Yeah. So it's going to be?
Negative.
Yeah. Easy as pie, right? A positive times a negative is a negative. We've known that since the dawn of time. Okay. And in this case, again, I want to keep my signs straight. How do I line this up? I would recommend putting the one with more digits on top. That's just a personal preference of mine. And I don't line up the decimals in this case, right? And then we just do a long multiplication problem. You guys done one of those in a while? Practice it. 9 times 7 is 63. 9 times 0 is 0 plus 6. 9 times 4 is 36. 0, 21. 3 times 0 is 0 plus 2 is 2. 3 times that's 12. And I ran out of room, so I'm going to have to scooch this over. And then we tally everything up. 3, 7, 851. And then you remember you count the decimal spots, so there was 3, so I go 1, 2, 3. And my answer is negative, don't forget the sign like James said, negative 15.873. Now actually practice doing that type of thing, fellas. And I know, again, we wear big boy pants now, don't we, Joe Edwards? Joe, you wearing your big boy pants today? Yeah, okay, there you go. So like we don't normally sit and do this type of calculation. Normally we'd slap it down on the calculator. Right? But the notion is that if you don't understand the process of how this works with easy little rational numbers, then when I start asking you guys to multiply things like polynomials together, or if I start asking you guys to multiply things like in scientific notation, then the fundamentals won't be there. All right. Now, speaking of scientific notation, do you guys work much with that in your middle school classes? Have y'all done much work with scientific notation before? I'm getting some heads shaking. Anybody at home? Yay, nay? Not so much?
Yeah,
All right.
kind of.
Just un poco day, a little bit. All right. The notion of scientific notation is what? Okay. It's when we have to deal with really, 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 really big numbers, or really bitty, bitty, teeny, tiny little small numbers. I don't know why y'all are being so quiet today. That was mosquitoes up here with me. That's what I get. Because when we are dealing with calculations, like if I said, Grady, how far away is the moon? Grady, do you know? I was talking to George. I'm sorry. George, how far away is the moon? Do you know? No, we don't know how far away the moon is. Does anybody know? Somebody Google it at home and tell me how many miles away the moon is, okay? That's a big number, though, isn't it? Relatively speaking, for like you and I, that's a big number. We'd probably calculate it in miles, and it would probably be, like 683 million miles, something like that, okay?
200. The moon is 238,900 miles.
238,000 miles. Okay, so
900.
It's a big distance. I would want to represent a big number like that using scientific notation. Now, here's how we break down scientific notation. Look at this example. Example 4, we're going to start with an easy one. Okay. Get myself. Whoop, what just happened? What just happened? All right, hold on, fellas. Now we're cooking. All right, I got more room. All right, so what we're going to do is we're going to take the decimal, which at this example is right there. Okay, and we're going to slide it to the left. How far? How far should I go? 1, 2, 3. Is that enough?
No, all the way until there's only one digit ahead of the decimal.
7. Very good. We're going to put it right there. You want to slide it all the way until there's only one significant digit to the left of the decimal. So how many spots did I have to move that?
7.
Okay. So you count the spots 1, 2, 3, 4, 5, 6, 7. And then that's what you're going to say times 10 to the power of. Okay. Now you say, well, wait a minute, what? 10, we work at a base 10 system. Okay. So 10 to the power of 7 means that I would be multiplying 1.53 times, I think it's maybe 10 million, if I'm not mistaken. Okay. And that would therefore move the decimal back over to the right. But this is a much more convenient way of writing it, and especially when you consider the shorthand notation that you'll sometimes see on a calculator. 1.53 and then a capital, but a shrunk down capital E, and then the number 7. Either one of these, those are both synonymous. Those are both the same thing, notation-wise. You probably have seen the one on the top, and then unless you've used a calculator recently, maybe you haven't seen the one on the bottom, but be comfortable, be familiar with both of them, okay? So that's a big number, right? That's a really big number. What is that? That's 1, 2, 3, 4, 6, 15.3 million, okay? Now, here's a really small number. Actually, let's do it this way. I'm gonna come over here. Yeah. All right, suppose I give you really teeny tiny, like maybe the width of that mosquito's leg that I just crushed, okay? Maybe that is 0.000000000478 units. I don't know, whatever, inches. We'll say it's inches, okay? Maybe that's the width of a mosquito's foot. in terms of inches. So what I want to do is, obviously, if I'm working in calculations with this, I don't want to sit there and have to write out all those zeros every time. So what I'm going to do is I'm going to shrink it down. I'm going to compress it, sort of like a zip file, if you will. I'm going to compress it by counting the number of spots I have to move the decimal to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And just as we said a moment ago, we want to move the decimal such that there's only one significant digit to the left. So that's 13. So this one's going to be 4.78 times 10. Now, I don't want to say to the 13th power.
Negative.
10 to the yeah, because 10 to the 13th will be a huge number. This one's going to be negative 13. Okay. Now, I haven't taught you guys much about negative exponents just yet. Suffice it to say that a negative exponent, okay, in the context of scientific notation, means we're dealing with a really, really, really little teeny tiny number. And here's my alternate notation. 4.78 times 10 to the negative 13. Okay, so we can see it either way. See it either way. Now, one of the things I absolutely hated, and if anybody's mom or dad is a science teacher, or if you guys are going to go back to your school today and see your science teacher, please don't tell them I said this. But when I was in school, I took 1 year of chemistry when I was in high school, and I took 1 year of it when I was in college. There was a cute girl that I was interested in. She was a chemical engineer, and I thought, ooh, I'm going to take, because I got to pick. I could have picked my science class to go along with my math major, and so I thought I'm gonna take that class that she's taken. So I took chemistry. It was a terrible mistake on my part. I hated chemistry. Don't ever do something just because you have a girl that's doing it that you're interested in. Okay? Who are you staring at over there, Jack? Who are you shooting daggers at? We're looking at Will Edwards. Will. Well, learn from my mistake, Wilbur. You know, I took chemistry and it was a pain in the neck. My first year teacher, the first semester, I had Dr. Margaret Cooper, who's a sweet lady. We called her Dr. Grandma because she was literally 90 when she taught that class. She was older than dirt. She used to tell us stories about how she and Louis Pasteur used to go out on dates. Okay, she was that old. But anyway, she didn't teach us a whole lot other than, you know, some of the basics. And she would just tell us stories. And I thought, man, this chemistry stuff's easy. And then I got, my next semester, I got Dr. Merritt was his name. And he was legit in your face. I'm going to drop an elbow of chemistry knowledge on you every day. And I struggled mightily. And one of the things I struggled with was called significant digits or significant figures. Y'all ever dealt with sig figs before? Okay. So sig figs pretty much means, how many digits do I want to keep in my calculation? Like in this example, I had 3. 4.78. That's 3 significant figures, right? But in some applications, you might need more. Some applications, you might need less. It would just depend on the particular chemistry problem you're dealing with. And I always stunk it up at sig figs, okay? So beware one day when you guys get into chemistry and y'all start dealing with scientific notation and you hear the dreaded phrase sig figs, okay? I want you to think. You gotta be on your toes. Be prepared for the difficulties, all right? So I taught you now how to convert a big number to scientific notation like I did in blue, and a little number in scientific notation like I did in orange. Questions? You left your lunch at your house? Yes, text your dad. Can't go without lunch today. Once in a while, back in normal circumstances, my 8th graders, and actually some of y'all might do this, would roll up in here with their lunch boxes. Did you guys, anybody bring a lunch today? Okay, good. Several of you guys did. George, you buying today? What are they serving? Okay. Been there, done that. Got the t-shirt. No, once in a while an 8th grader, like in years past, would leave their lunch in here. And I try to be good and I try to see it and grab it and run it out there and give it to the kid before he leaves. But once in a while I wouldn't find it, until like an hour into school, at which point I would usually just open it and eat it. And I would kind of feel a little bit guilty about that, but not much. And until one day I opened up a kid's lunch, and I kid you not, this is what he had. Okay. He had a Go-Gurt. You know what Go-Gurt is. He had a Go-Gurt. He had some Starbursts, and he had a mini Powerade, a little teeny tiny Powerade. Now, what the dump kind of lunch is that? You know what I'm saying? Some of you guys are like, that sounds like a great lunch. No way, dude. You could at least throw in like a Slim Jim or something, get some kind of protein in there. But I digress. You guys pack your own lunch? There you go. Nice. I bet that kid packed his own lunch too. When we talk about scientific notation, we also want to be able to go backwards. Okay. One thing to keep in mind though is the signage of the actual number. The sign of this one in example 5 here, this one's a negative number. Okay. So my conversion needs to take that into consideration and just say, okay, my answer is going to be negative. And then I can put that on the back burner and not worry about it anymore. Okay, so as long as I remember my answer is going to be negative, I'm just going to kind of get this out of mind and out of sight and out of mind and just look at 7.03 times 10 to the negative fourth. Okay, the sign of the number does not affect the conversion of the number. If I were you, I would write that down. The sign of the number does not affect the conversion of the number. Okay. Now the sign of the exponent does. Oh yeah, it does. But the sign of the actual number does not. So I'm just going to put that on the back burner. I'll deal with it at the end. I know my answer is going to need to be negative at the end, so I'm just going to ignore it for right now. I'm not going to let it distract me. And then I'm going to look at, okay, so I got 7.03 times 10 to the negative fourth. So Andrew, is that going to be a big number or a little number? It's going to be a little number because of the negative exponent, right? So if I think about a little number, what that means is that I'm going to need to move that decimal which direction? Somebody at home tell me, which direction should I move that decimal?
Left.
To the left. We're going to move it how many spots?
4.
1, 2, 3, 4. And guys, I know it's juvenile or elementary or whatever, but actually draw it out. Actually make the little humps, because what do you get to put in the humps?
Zeros.
Put some zeros right there. Okay, and you'll get it right every time. And remember that our problem was negative to begin with, so our answer is going to be negative, and it's going to be negative 0.000703. All right, and we've converted it back into standard form, standard notation. All right, now that's pretty straightforward, but if you skip out on the details, then you can kind of screw that up. Okay. Now, we won't deal with a lot of scientific notation in this class. This is more one of those things that I'm kind of trying to teach you a little bit about so that you can use it in your science or engineering class. Okay, if you eventually go into that kind of class when you get into high school, right? But we won't use it a lot this year, scientific notation, not so much. Okay, y'all ready to move on? Any lingering questions?
I actually have a question.
Yeah, lay it on me, Lewis.
I forgot to ask this at the start, but on the homework, could you explain how to square fractions? I never knew how to do that.
Yeah, bro, that's easy. Square the top, square the bottom. Can we look maybe down here at number 231, perhaps? All right, so let's look at, I'll highlight for you, Lewis, this one right here, okay? So first of all, if you're squaring a fraction, you want to take the sign into consideration. If it's a negative fraction, we know a negative times a negative is positive, so my result here is going to be positive. And then to square a fraction, we just square the top, square the bottom. So I look at 2 is the top, or negative 2 really. And then I say, all right, Lewis, negative 2 squared is 4. And then we say, all right, well, let's square the bottom. Okay, 3 squared winds up giving me 9. And then the same thing with raising it to the third power, check that out, that part right there. Like if I wanted to cube a fraction, I'm just multiplying the top by the top by the top. In other words, I'm cubing negative 1. So when I cube negative 1, negative 1 times negative 1 times negative 1 gives me negative 1. And then when I cube the bottom, 2 cubed, 2 times 2 times 2 winds up giving me 8.
Okay, thank you.
Yeah, man, you're welcome very, very much. And the sort of the background rule for that, you guys, is if I've got A over B to the n power, that's A to the n over B to the n. Do you guys already know that? That's a little background rule. And most of the times that we deal with that, well, I like to go ahead and split it up. Once in a while, you're going and you're taking the long route. So like A over B times A over B times dot, dot, dot times A over B, however many n factors there are. And then of course, you would just do top with top, bottom with bottom. And you say, oh, well, look, there's n A's. And that's where that numerator came from. And there's n b's, and that's where the denominator would come from. That's sort of the background rule. All right, a little tough love here. I appreciate you guys being here, but if you're just sitting looking, you're not doing much. I love it when I see pencils writing. I just put a rule up on the board in red And so this is kind of the background of what's going on. If I were you, anything I put on the screen, I'd put in my notes. Just, you know, little hint, hint, wink, wink there. You smelling what I'm stepping in? Yes, Coach Morgan. Sorry, Coach Morgan. All right, moving on. Tough toenails if you didn't write it down already. Let's look at the last couple of examples. I think I got about 4 or 5 minutes with you guys. Maybe 3. 3.5. All right, we're dividing. Ooh, we got to divide by some decimals. What about the signage? How do I keep straight? Mossy, what do you think about the signage of this one? Positive, negative, or I don't know? Valentino, can you hear me?
Yes.
Speak up, buddy. I don't know if I'm hearing you.
Positive.
Positive. Okay, yeah, I barely heard you. Yeah, positive. That's because a negative times a negative is a positive, and division is defined as what? By the reciprocal. Good. Reed Johnston, remember that from last week. So if division plays by the same rules sign-wise as multiplication, then we know a negative over a negative, the negatives cancel each other out. So really this is a matter of saying, okay, I've got 25.65, that's my dividend, divided by 0.06, that's my divisor. What's the little trick that we learned in elementary school? What do I do there? Go ahead, Jay.
You have to make the divisor an even number. It cannot have a decimal.
Instead of saying even, let's say integer. We have to make it an integer, right? And to do that, I move it over 2 spots to the right. Now, the whole notion of, like, your elementary school teacher probably didn't tell you this, but the whole notion of why you're able to do that is what we just got through talking about, okay? When I scoot a decimal to the right a couple of ways, I'm multiplying by 10 to the 2nd power. So this, in essence, when I look at this original fraction of 25.65 over 0.06, in essence, what we are doing is we are saying, let's multiply the top by 100 and the bottom by 100. Did you know that? That's what we're doing when we scooch this decimal to the right 2 units. Okay? So now the problem is, as Jake was telling us, now we've got a divisor that is an integer. And it just so happens that the dividend is also an integer. It won't always be the case, but that's all right. And then we can start our division problem. We can start our long division problem. Do you guys remember how long division works? Right. 6 doesn't go into 2, so it goes into 25 4 times. 24, 16, bring 1 down, pass it around. It goes in twice. 12, we get 45. What does it go in? 7 times. 42, bring a 0 down, and it goes in 5 times. So we wind up with 427.5. Practice long division, fellas, because we're going to do it again later in the year with polynomials. And those steps that we just practiced, you know, you might need to knock the rust off a little bit and say, ooh, I hadn't done that in a while. But there you go. Okay, so questions on how that worked? A little review for you about adding, subtracting, multiplying, and dividing decimals today. All right, I'll probably give you guys a little homework assignment online this time through Delta Math. You guys are all signed up for my Delta Math class, aren't you? Yeah. All right, so I'll either email about that or I'll post it.
I'm not assigned to. I'm not on that.
Paul. Shoot me an email, Paul. I'll give you some instructions over the email.
All right.
Sound good, brother? Fellas, it is that time, so live Jesus in our hearts. I hope you'll have a fantastic day. Grady, I hope they're serving. George, I hope they're serving something tasty at lunch. Thanks, fellas. Y'all be good.
All right.